Hello, today I'm going to present the history of reduced instruction set computers, then talk about the switch to domain-specific architectures, and then talk about a new approach to benchmarking embedded computing. So what are the lessons from the last 50 years? The first is that raising the hardware-software interface creates opportunities for architecture innovation, going from C and Python in traditional programming languages to more machine learning advances like TensorFlow and PyTorch. The second is that benchmarks in the marketplace ultimately settles these architectural debates, like the traditional benchmarks SPEC and the transaction processing console, and more recently MLPerf. Let me do a quick review. What is instruction set architecture and why is it important? Well, software talks to hardware using a vocabulary, and the words of that vocabulary are called instructions. And the name of the vocabulary itself is instruction set architecture, often abbreviated ISA and sometimes pronounced ISA. It's the most important interface since that determines what software can run on the hardware. And in fact, software is distributed in those words or instructions. So let's go back more than 50 years, and IBM had this big problem. They had 4 incompatible lines of computers. Each had its own instruction set architecture and basically its own operating system, software stack, and its own markets. So IBM engineers came up with this bold idea to unify all the markets and niches into a single instruction set called the IBM System 360. Now, the hard part then and now is control. The data path is the arithmetic unit is pretty easy. To figure out how to do control, they went to Turing Award winner Maurice Wilkes, who had this idea that he called microprogramming. His insights is that logic was much more expensive than read-only memory or alterable memory, but ROM is cheaper and faster than RAM, so you would specify control as a memory, and they called every word of that memory a microinstruction, and the programming of that memory microprogramming.